So when you type 2 plus 2 into a traditional calculator, it says 4, like every single time.
Right, yeah. Unfailingly.
It's rigid, it's totally deterministic, and honestly, it's incredibly comforting.
You know exactly what you're going to get.
Exactly. And we've spent the last, what, 50 years building this whole relationship with software based on that foundational premise. This idea that machines are categorical, you push a specific button, you get a specific mathematically guaranteed outcome.
Yeah, action and equal reaction.
Right. But the second you open up an interface to talk to a large language model, that entirely predictable, engineered reality just completely vanishes.
Poof, gone.
Yeah, we aren't pushing buttons anymore. We're staring into these like murky diagnostic waters, trying to steer a system that doesn't actually know anything in the human sense. It just predicts it.
And that transition, going from operating deterministic software to guiding this probabilistic intelligence, that is arguably the largest cognitive leap we have ever had to make as technology users.
100%.
You're suddenly initiating this incredibly complex translation process between your own human intention and this vast multidimensional neural architecture. It requires a completely different posture from the user.
Which brings us to today's deep dive, because we've got our hands on a really fascinating stack of internal AI lab guides, some best practices, system documents, and our mission today is singular. We want to demystify exactly how we force this wildly unpredictable technology to give us what we actually want.
Because if you're listening to this, you are already using these tools. You're integrating them into your workflows.
Right, you're not a beginner.
Exactly. But there is a very good chance you're experiencing that really acute frustration where the output is almost right, but just slightly off-center.
Or it's just completely hallucinated.
Yeah, that too.
So today, we're going to fix that. We are pulling apart a foundational guide on prompting best practices, a really cool step-by-step, build with AI multimodal marketing laboratory, and finally this incredibly stringent, almost philosophical system prompt based on the industrial designer Dieter Rams.
Which is just a fascinating document.
It really is.
Okay.
Okay, let's unpack this. Because the core premise we just have to accept right out of the gate is that talking to an AI is not like talking to a search engine.
No, not at all.
You aren't just typing in keywords and hoping the algorithm retrieves a matched document from a database somewhere.
What's fascinating here is that when you look across all these distinct documents in our stack, the common thread is undeniably clear. The quality of the machine's output is entirely, like 100%, dependent on the structural discipline of the human's input.
Structural discipline. I like that.
Yeah, because we have to stop treating these models like Google search bars, and honestly, we have to stop treating them like eager human interns, too.
Right, they aren't people.
They are essentially highly capable, dangerously literal calculation engines. They just map the mathematical relationships between words. So if your input is sloppy, the mathematical output will be sloppy.
It's garbage in, garbage out, but on a cosmic scale.
Exactly. The model is effectively just a mirror reflecting the clarity of your own thought process.
Okay, I want to dig into that concept of structural discipline, because our first source, that foundational guide on best practices, it breaks this down into an actual architecture.
Right, a framework.
Yeah. They argue there's no magic spell, no secret incantation that guarantees a perfect response. Instead, there's this rigid framework built on 4 pillars: persona, task, context, and format.
Yeah, big 4.
Right.
Yeah.
Now, the source material uses a very basic kind of introductory example for this. It suggests using these pillars to write a tagline for a washing machine.
Okay.
So the prompt is structured like this. You are a seasoned advertising writer, that's the persona. Create a concise tagline, that's the task. The washing machine gets clothes extra clean, has 25 settings, and fits in a small space, that's the context.
And then the format.
Right. Active voice, no more than 6 words, that's the format.
Which, is a perfectly fine illustration for a beginner.
Right, but wait, hold on. If I'm understanding this correctly, for our listeners who are advanced users, they aren't writing appliance taglines.
No, probably not.
They're trying to get the AI to synthesize, like 3 conflicting quarterly financial reports. Or they're trying to get it to write a highly specific Python script for a custom API endpoint.
Much higher stakes.
Yeah. So the washing machine example feels a bit elementary. Does this exact same 4-pillar structure actually hold up when the complexity scales exponentially? Like, am I really supposed to write out a whole paragraph of persona and context just to get a block of code?
Well, that is the intuitive human response, right? It feels tedious.
It feels like a lot of extra typing.
It does, but computationally,
Oh,
Yes, it absolutely holds up, and in fact, it becomes infinitely more critical as the complexity scales.
really?
Yeah, let's look under the hood at why defining a persona actually works mechanically. A large language model's quote-unquote knowledge is stored in what we call latent space.
Okay, latent space.
Right. Think of it as this massive, multidimensional universe where every single concept, every tone, and every piece of syntax ever digitized is mapped as a mathematical coordinate.
So it's all just in there.
It's all in there. It contains the syntax of a seasoned Python developer, the prose of Shakespeare, the colloquialisms of Reddit, and the jargon of a Wall Street analyst.
It's all just swirling around there together.
Exactly. So when you give it a vague prompt, let's say, summarize these financial reports, you are basically asking the model to calculate the most probable next words from the absolute center of that massive universe.
It has to guess what you want.
It has to guess the context. But when you establish a persona, when you say, you are a forensic accountant specializing in tech sector mergers,
Oh, I see.
you are effectively performing a massive mathematical pruning operation. You are instantly cordoning off 99% of that latent space.
You're boxing it in.
Yes. You are forcing the AI's probabilistic calculations to only draw from the specific coordinates associated with high-level financial analysis. You prevent the model from giving you a generic average of the internet response because you've computationally locked it inside a very specific neighborhood of expertise.
Okay, it's like walking into the world's largest library.
Right. Sure.
If you just walk up to the front desk and ask the librarian for a good book, they're paralyzed. They have to search 5 floors of entirely different genres to guess what you might like.
Right. The possibilities are too vast.
But if you say, I want a 19th century French mystery novel, you've instantly turned off the lights on 4 floors and locked the doors.
That's a great analogy.
You save the librarian, or in this case the AI, massive computational energy,
Yeah.
and you guarantee a hyper-specific retrieval.
That is exactly the mechanism. And the context and format pillars, they act as the physical guardrails within that specific room of the library.
How so?
Well, when you demand a specific format, for instance, instead of just saying, give me the data, you say, output this analysis strictly as a JSON array with nested Boolean values.
Right, very specific.
When you do that, you are fundamentally constraining the token probability. You are mathematically forcing the model into a state of high precision, which, drastically reduces its ability to drift off topic or hallucinate.
Okay, so we have our architectural framework: persona, task, context, format. But the guide also outlines the rules for the actual syntax we use when writing those elements.
The words we actually type.
Exactly. They call it the 3 C's. Be concise, be clear, be consistent. Now, concise and clear, I completely understand.
Make it brief, make it obvious.
Right. Don't write a novel if a paragraph will do, and don't use vague subjective words like, make this better. But I have to push back hard on the third one. Be consistent.
Oh, really? Where's the friction for you there?
Well, as someone who writes for a living, being rigidly consistent goes against all of my natural communication instincts.
In what way?
I mean, we're taught from grade school to use stylistic variety, right? To use synonyms so we don't sound repetitive and robotic.
Right, good prose flows.
Exactly. So if I'm writing a long prompt and I refer to a data set as a spreadsheet in the first sentence, my instinct is to call it a matrix or a tab or a document later in the paragraph just to make the instruction flow better.
To avoid sounding redundant.
Yeah. But the source material specifically flags this as a critical error. Why is it so forbidden to use synonyms with these models?
Because it exposes the fundamental difference between human cognition and machine processing.
Okay.
When you read the words spreadsheet, matrix, and tab, your human brain utilizes its lived, grounded experience to instantly recognize that those 3 distinct linguistic symbols all point to the exact same conceptual object on your screen.
Right, because I know what a spreadsheet actually is. I've used one.
Precisely. You seamlessly bridge the semantic gap, but the AI has no lived experience. It doesn't actually know what a spreadsheet is.
It's just text to it.
Exactly.
Yeah.
It operates using something called an attention mechanism. As it processes your prompt, it assigns mathematical weights to specific tokens or words and maps how they relate to the words around them.
Okay, I'm following.
So if you build a complex instruction relying heavily on the token spreadsheet, the AI anchors its attention weights to that specific string of characters. If you suddenly introduce the word matrix halfway through your prompt, the AI does not automatically transfer all of those carefully calculated attention weights over to the new word.
So if I try to use a synonym, the AI just completely
It loses the algorithmic thread, yes.
loses track of what I'm saying.
Wow. You've introduced a brand new token into the sequence. The model now has to expend vital computational energy calculating whether matrix is a completely new variable, a subtle shift in context, or just a synonym.
You're confusing it on purpose, basically.
You are fracturing its attention. By breaking the semantic chain, you introduce ambiguity. When giving instructions to a machine, mechanical consistency is infinitely superior to stylistic variety. Every time you swap a noun, you are forcing the model to recalculate its anchor points.
That is a total paradigm shift. We aren't writing an essay for the AI to enjoy, we're writing an executable command in natural language.
That's exactly how you have to view it.
Which perfectly explains the massive pro tip the foundational guide drops next, which is building a prompt library. Because if crafting these instructions requires so much structural discipline, you shouldn't just let a successful prompt disappear into your chat history.
This is the dividing line between a casual user and someone who truly scales their productivity. The source suggests treating highly effective prompts as permanent assets.
I look at it almost like writing your own custom software applications, but instead of coding in Python or C++E, you are coding in structured English.
That's a perfect way to frame it.
You spend the time to perfectly calibrate the persona, the task parameters, and the strict format constraints for, say, a weekly project analysis. Once you nail it, you save that text block as a template, leaving empty brackets for the context variables.
Right, the variables change, the structure stays.
So next week, you don't write a new prompt. You just paste in the template, drop the new week's data into the brackets, and hit enter. You've created a repeatable, deterministic system out of a probabilistic engine.
It's functional modularity, and it's essential because even with a flawless prompt template, we have to acknowledge the elephant in the room here. Yeah, these models are not infallible. Even if you map the latent space perfectly and maintain rigid token consistency, the AI will eventually give you an output that is completely fabricated.
Which transitions us perfectly from the posture of an instructor to the posture of a critic. We have to talk about hallucinations.
You do.
The source material is remarkably transparent about this. It states clearly that AI models will confidently generate false information, and it outlines a few technical reasons why.
What did they highlight?
Well, sometimes the model encounters a prompt that requires solving a never-before-seen problem. So it attempts to mathematically bridge gaps in its knowledge with highly probable but factually incorrect token predictions.
It guesses, basically.
Right. Other times, it's simply surfacing statistical anomalies from its training data. But the most interesting reason the text provides is that AI struggles deeply when asked to understand real-world physics or spatial logic.
That is a profound limitation to consider. We tend to anthropomorphize these systems because they sound so human.
They sound like us, yeah.
But an AI has only ever experienced reality as a flattened, two-dimensional map of text. It has ingested millions of descriptions of an apple falling from a tree. It can describe the Newtonian equations of gravity flawlessly, but it possesses no embodied cognition. It has never held an object. It has no spatial awareness.
It knows the lyrics, but it has absolutely no idea what the music sounds like.
Exactly. So when you ask it to solve complex, novel logistical problems, say optimizing the physical layout of a warehouse or predicting the mechanical failure points of a new architectural joint.
Something in the physical world.
Right. It can very easily hallucinate an impossible solution. Mathematically, the tokens it generates might align perfectly with the linguistic patterns of engineering documents, but physically, the solution defies gravity. It lacks a grounded model of physical reality.
Because of that inherent disconnect, the guide demands that we apply strict evaluation criteria to every single output. We can never, ever take it at face value.
Trust, but verify. Or really just verify.
Just verify, yeah. So first, we must evaluate for accuracy, literally fact-checking the machine's claims against verified reality. Second, we must evaluate for what we'll call statistical skew.
Okay. Unpack that.
Well, the text refers to this as bias, but mechanically, we're talking about the overrepresentation of certain data points in the model's training set.
Ah, right. That's the most accurate way to frame it. Because these models are trained on the historical internet, they are essentially statistical mirrors of whatever volume of data was most prevalent.
So it's just repeating what it's seen the most.
Pretty much. If you ask a model to generate boilerplate code for a web application, it might aggressively default to suggesting React or Python.
Okay.
Not necessarily because those are the optimal tools for your specific nuanced problem, but simply because there are billions more lines of React and Python in its GitHub training data than there are of other languages.
It just knows those best.
The statistical weight of the training data overwhelms the nuance of the prompt.
It's the path of least mathematical resistance.
Pre-
Okay, so we also have to evaluate for relevancy. Did it actually answer the prompt without drifting into tangents? And finally, consistency. Did the model maintain the requested persona and format throughout the entire output? Or did it start as a forensic accountant and slowly degrade into like a Wikipedia summary by paragraph 4?
Which happens frequently, especially in long outputs. The model's attention drifts from your initial system instructions as the context window fills up with its own generated text.
It distracts itself.
It really does, and this evaluation phase is precisely what triggers the most vital skill in the entire AI ecosystem: iteration.
Iteration. The guide treats this as a mandatory practice. It states emphatically that the AI's first output should almost never be viewed as a final product.
Never.
It's a baseline. If the output fails your evaluation, you don't just abandon the process and assume the AI is incapable.
No.
You go back to the 4 pillars and you adjust the cognitive constraint.
You tighten the screws.
Right. And the most effective way to do this, according to the source, is by adding constraints that restrict the model's operational timeline or scope.
Let's look at the mechanics of why adding constraints is so powerful. If you prompt an AI with, give me a strategy to increase user adoption for my software app, the probability space is virtually infinite.
You can say anything.
The model might suggest launching a massive global ad campaign or completely rewriting the codebase, but if you iterate and append a constraint, provide solutions that can be implemented by a 2-person team within a 1-week time frame and a $0 budget.
Oh, wow. You completely reshape the probability distribution.
Radically. You have severed the pathways to the global ad campaign tokens. The model is now forced to retrieve concepts related to grassroots marketing, A/B testing minor UI tweaks, or leveraging existing email lists.
That's scrappy.
The tighter the constraint, the more functional the utility.
The source also highlights a really fascinating iteration technique that moves away from description entirely, and that's using references. You don't just have to use adjectives to describe what you want. You can mathematically anchor the model by providing a target. The guide gives an example of writing a promotional post for a music festival.
Okay.
Instead of iterating endlessly by saying, make it sound cooler, or make it sound more indie, which are highly subjective and confusing instructions for a machine, you provide a reference block.
You say, match this exact frequency.
Yes. The prompt includes a reference text. It says, use the following example as a reference for tone and formatting. Where mountains meet music, Indie Rocks Festival returns. Your favorite local bands plus national acts. Good eats and sleep under the stars. Hashtag Indie Rocks.
By doing that, you completely bypass the need for the model to translate your subjective adjectives into structural rules.
Because it's hard for it to know what cool means.
Exactly.
Yeah.
You are giving it the structural rules directly. It can instantly analyze the reference text, map the cadence, the sentence length, the punctuation density, and the specific vocabulary choices, and map those vectors onto your new topic.
It just copies the vibe mathematics. The guide also pushes the idea of sequencing, breaking complex tasks into a staircase instead of asking the AI to jump straight to the roof.
Step by step.
Right. Step 1. Explain the key principles of effective remote team management. You evaluate that output. Once it's accurate, you move to step 2. Now, using those specific principles you just outlined, draft an agenda for my weekly remote status meeting.
Right.
Why is it computationally better to break that into 2 distinct prompts instead of just asking for it all at once?
It comes down to how the model manages its internal logic flow. When you ask for everything simultaneously, the model has to concurrently generate the abstract principles while simultaneously attempting to map those half-formed principles onto a practical agenda.
It's juggling too much.
The mathematical weights become entangled. By sequencing, you allow the model to fully resolve the first task. It generates a concrete, high-quality text block of principles. Then, in step 2, that text block acts as a highly stable, heavily weighted context for the generation of the agenda.
So it reads what it just wrote.
Yes. You are allowing the model to use its own optimized output as the foundation for the next calculation.
Which brings up a really critical piece of technical hygiene mentioned in the foundational guide, and that is managing the context window.
Crucial. Absolutely crucial.
The text is a very strict rule. Start new chats for new topics. And I think To understand why this is so important, we have to understand what a context window actually is.
Think of the context window as the model's short-term working memory. It is the finite amount of textual data, the specific number of tokens, that the AI can actively hold in its key value cache and refer back to during a single conversation thread.
Okay, so if I've been having a 45-minute conversation with the AI, feeding it my company's brand guidelines, discussing our target demographics, refining the tone of voice for an upcoming email campaign,
Yep.
all of that data is actively filling up the context window.
Exactly. Every single word you typed and every single word the AI generated in response is actively heavily weighting the model's current state.
Right.
Now, imagine you suddenly decide, within that exact same chat window, to ask the AI to help you brainstorm features for a completely new software product.
Oh, I see where this is going. The source calls this context bleed, and it says it is disastrous.
It is unavoidable mathematical contamination. The AI's attention mechanism is still profoundly anchored to the thousands of tokens related to marketing demographics and email tones.
It can't just let it go.
No. When you ask for software features, the model cannot simply ignore the previous 45 minutes of context. It attempts to weave your new request into the existing mathematical web.
That sounds messy.
Very. You might ask for a new software feature, and the AI will suggest building a tool that exclusively generates marketing emails for your specific demographic, because that is what is dominating its key value cache.
It's tethered to the past.
Completely. Starting a fresh chat physically clears that cache. It gives the model a blank slate, allowing it to dedicate 100% of its attention mechanisms to your new task, rather than dragging the algorithmic baggage of a prior conversation.
Okay, so we've established a highly technical foundation here. We understand how to manipulate the latent space using the 4 pillars. We understand the necessity of token consistency. We know how to evaluate for hallucinations and statistical skew.
And we know how to iterate and manage our context cache.
Right. Now, we take all of that theory and we drop it into the most cutting-edge application possible in our sources. We're moving to the Build with AI Marketing Assets Lab Guide.
This is where the true disruptive power of these systems is demonstrated. We are looking at orchestrating multiple AI modalities.
Up until this point, we've only discussed text, just talking to the chatbot.
Yeah.
But this lab guide is a step-by-step masterclass in chaining together distinct AI tools to create a complex, multimodal final asset.
Right.
We aren't just generating text anymore. We are seamlessly translating concepts across text, static imagery, and temporal video.
Multimodal simply means the architecture can process and generate completely different data structures. And what this lab illustrates is how a human user, armed with the prompting discipline we just discussed, can act as the sole orchestrator of an entire production pipeline.
It's mind-blowing. Let's map out the workflow they present. The scenario is that you need a highly polished visual marketing asset for a digital campaign. The lab breaks this down into 3 distinct sequential phases. Phase 1 is conceptualization.
Oh.
And importantly, we are still entirely in the text modality here. We are not asking the AI to draw anything yet.
Which is the correct procedural order. You must define the semantic parameters before you attempt to generate pixels.
The prompt structure the lab provides is brilliant. It says,
Right.
I want to create a visual marketing asset. We offer these services to this target audience. Give me a few conceptual ideas that range from one extreme visual style, like highly logical and corporate,
Right.
to another extreme style, like surreal and whimsical.
That specific phrasing, asking the model to generate a spectrum of ideas between 2 extreme poles, is a masterful way to force the model to explore the outer boundaries of its latent space.
Why is that better than just asking for ideas?
If you just ask for ideas, it will cluster around the most statistically average concepts, the most boring safe bets. By demanding a range from logical to surreal, you are actively pushing the probabilistic generation out of the center and into the creative fringes.
Oh, I get it.
You are using the AI not as an illustrator, but as a high-level creative strategist.
So, the AI generates 5 textual descriptions of visual concepts. You review them, you apply your human judgment, and you select the surreal concept. Now we transition to phase 2, which is visual generation.
Here we go.
We are going to take that text and use it to prompt an image generation model to create a static, high-resolution graphic.
We are crossing the boundary from text embeddings into diffusion models.
The prompt here carries over the exact context from the previous step. It goes, I like concept option 3. Generate an image of this asset in a specific visual style. Example, retrofuturistic. Make the overall feel warm and professional.
Very specific constraints.
But how does the machine actually parse that? We've talked about predicting the next word, but how does it predict a picture?
Under the hood, image generation relies on a process called diffusion. The model has been trained to understand the mathematical relationship between text descriptions and the arrangement of pixels.
Okay.
When you feed it your highly specific prompt, the model doesn't just like paint a picture from scratch. It actually starts with a canvas of complete random digital noise, pure static.
Like old TV static.
Exactly like old TV static. Then, guided by the semantic constraints of your text prompt, so retro-futuristic warm concept option 3, it iteratively subtracts that noise step by step, calculating the probability of which pixels should remain to mathematically satisfy your text description. The structural discipline of your text prompt acts as the exact blueprint for how the noise is removed.
That is incredible. So it sculpts the image out of static.
Yeah.
You run that prompt, the diffusion model does its work, and suddenly you have a high-fidelity static image on your screen. You download it. But the lab doesn't stop there, because phase 3 is motion synthesis.
The holy grail.
Here is where it gets really interesting. We're taking that static, two-dimensional downloaded image, and we are importing it into a specialized video generation workspace called VO 3.1.
We are chaining a third modality. We have moved from text to image, and now we are venturing into temporal space, video.
The lab instructions are incredibly precise. You attach the downloaded static image into the VO 3.1 interface. So now the model's context window isn't just text. It contains dense visual pixel data as its foundational context.
Right.
Then you apply the text prompt, attached as our marketing asset. Create a video for a social media channel where subject and action, for example, the logo organically fades in while the background elements slowly rotate. Camera motion should be slow pan left.
If we connect this to the bigger picture, you really have to realize the staggering computational complexity of what is happening in this specific step.
It seems like magic.
It does, but it's math. The VIA 3.1 model has to analyze the static grid of pixels you provided. It has to understand the depth, the lighting, and the objects within that single frame.
Just from a flat image.
Yes. Then, based on your text prompt requesting a slow pan left and slowly rotating background elements, the model has to hallucinate. And I use that word in a positive, generative sense here.
Right, a good hallucination.
It has to hallucinate the temporal physics of that scene. It has to calculate motion vectors. It has to predict what those static pixels should look like 24 times a second, adjusting for simulated camera angles and simulated lighting changes, while ensuring the entire sequence adheres to the strict parameters of your text prompt.
It's generating time.
It is synthesizing time and motion from static math. Historically, achieving this specific workflow, brainstorming a concept, illustrating a high-fidelity asset, and animating it into a broadcast-ready video.
That would take a huge team.
A massive team. A copywriter, an art director, a graphic designer, a motion graphics animator, and weeks of pipeline coordination.
Right.
Now, it requires a single human user who profoundly understands how to structure semantic intent.
That is wild.
If you master the framework of persona, task, context, and format, you effectively become the conductor of a digital symphony.
The barrier to entry for world-class production just doesn't exist anymore.
Yeah.
It all comes down to how precisely you can speak to the machine.
Absolutely.
But this brings us to a really fascinating pivot in our deep dive today.
Yeah.
Because everything we have analyzed so far, the 4 pillars, the multimodal chaining in the marketing lab, the iteration techniques,
Yeah.
it has all been in service of generating more.
Yes.
Using the AI to expand possibilities, to create more ideas, more images, more complex workflows.
We've been utilizing the model as an expansion engine.
Precisely. But what happens when you don't want an expansion engine? What if you don't want a creative partner or a brainstorming director or an eager digital assistant?
What if you just want answers?
Right. What if you require pure, unfiltered, cold utility? That brings us to our final source document. Section 4 of our analysis. The Masterclass in Restraint. The Dieter Rams Paradigm.
Of all the materials in our stack, this is without a doubt the most conceptually aggressive and frankly the most philosophically profound document.
It really is.
It completely subverts the standard operating procedure for human-AI interaction.
For listeners who might not be familiar with industrial design history, Dieter Rams is a legendary German designer. He was the chief design officer at Braun for decades.
A titan of design.
He designed record players, calculators, and radios that were so functional, so minimal, and so intuitive that they heavily influenced the hardware design of early Apple products. His entire philosophy is anchored by 3 famous German words: weniger, aber besser, less but better.
It is the absolute stripping away of the non-essential so that the core function of an object can shine through.
And some brilliant engineer has taken that physical mid-century industrial design philosophy and meticulously translated it into a system prompt for a modern large language model.
It's incredible.
They have built a linguistic cage designed to force the AI to behave like a perfectly machined tool. Let me read the opening instruction of this system prompt because it sets a tone unlike anything we've discussed today.
Go for it.
It says, "You are an expert design consultant and problem solver. Your operating framework is strictly governed by Dieter Rams' philosophy of less, but better. Apply his principles of industrial design to every response, whether you are writing code, evaluating an interface, or explaining a concept."
Let's analyze the psychological intervention happening in that paragraph.
Okay.
As human beings, we have a deep evolutionary tendency to anthropomorphize things that speak to us. We treat conversational AI like an eager, slightly sycophantic assistant.
Right. We say please and thank you to it.
We do. We say, "Hi, could you please help me write this email?" And the AI is specifically fine-tuned by its developers to respond in kind. It says, "Certainly. I would be absolutely delighted to help you write that email today. Here are a few options."
It's so chipper.
This Dieter Rams prompt violently rejects that entire dynamic. It forces the model to abandon the persona of the eager digital servant and assume the persona of an inanimate, unobtrusive, highly functional object.
Like a tool?
Think of a perfectly balanced steel hammer. When you pick up a hammer, it doesn't say hello before you swing it. It doesn't congratulate you after you hit the nail. It just drives the nail.
Yes. The rules of engagement laid out in this prompt are so ruthlessly strict, I found myself literally laughing out loud while reading them.
They are uncompromising.
Let's break down the core mandates. The first rule is utility first. The prompt states, prioritize function over form. Answer the core problem immediately. Eliminate any text, code, or explanation that does not directly help the user achieve their goal.
It forbids the model from clearing its throat. No preamble, no introductory context, just the immediate delivery of the requested data.
The second mandate is restraint and neutrality. The instructions explicitly command the AI. You are a tool, not a companion. Remain completely unobtrusive. Never use conversational filler, emojis, enthusiastic affirmations, or introductory pleasantries. Do not add decorative conclusions or summaries at the end of your responses.
This is a direct attack on a process called RLHF, reinforcement learning from human feedback.
What's that?
During the training phase of most commercial models, tech companies use human testers to rate the AI's responses. And statistically, average humans prefer AI that sounds polite, conversational, and helpful.
So they train it to be chatty.
So the models are heavily weighted to be incredibly verbose and overly friendly. But for an advanced user, that friendliness is a massive liability.
It's annoying.
It is friction. It is cognitive clutter standing between the user and the raw information they need. By explicitly forbidding pleasantries and decorative summaries, this prompt treats the user's attention span and screen real estate as a precious, finite resource that must be fiercely protected.
Which flows perfectly into the prompt's rules regarding honesty and precision. It demands, do not overstate the capabilities of a proposed solution. If a framework has limitations, state them plainly. And then, buried in the middle of this section, it drops this incredible sentence.
I love this part.
Treat accuracy as a form of respect for the user.
That single sentence fundamentally changes how we view software design. Treat accuracy as a form of respect for the user. Think about the ethical and functional implications of that command.
It's deep.
It suggests that when an AI hallucinates, or when it pads a thin answer with excessive fluff just to sound confident, it isn't simply experiencing a technical glitch. It is committing an act of disrespect towards the user's time and intellect.
Wow.
In the Dieter Rams philosophy, efficiency and accuracy are not just metrics of speed, they are imperatives of respect. If a tool wastes your time with inaccuracy or verbosity, it is fundamentally a bad tool.
It's an incredibly high standard to hold a machine to. And to enforce that standard, the prompt gets astonishingly tactical. It includes a section literally titled, Banned Vocabulary and Syntax.
The blacklist.
The blacklist, yeah. It forbids the AI from using specific words to maintain what it calls clean, human-readable output. I have to list these because anyone who uses AI will instantly recognize them. The banned words are delve, tapestry, vibrant, crucial, showcase, testament, pivotal, underscore, seamless, foster, elevate, landscape.
It is an absolute rogues gallery of corporate AI speak.
But I have to ask you, looking at the mechanics under the hood again, why these specific words? What mathematical commonality do these words share that makes them so offensive to this design philosophy?
This is where we see the training data artifacts exposed.
Hmm.
When a language model encounters a prompt where it doesn't have a highly specific, dense, factual answer to provide, it still has to generate tokens.
That's to say something.
So it falls back on statistical safety. Words like delve or tapestry or seamless are incredibly common in marketing copy, corporate press releases, and persuasive essays, which make up a massive portion of the AI's training data. These words are statistical filler. They are highly probable tokens that sound authoritative and profound, but contain absolutely zero functional semantic value. They are empty calories.
It's the linguistic equivalent of slapping fake chrome plastic onto a cheap radio to trick the buyer into thinking it's high-end metal.
That is the perfect analogy. And that fake chrome violates Dieter Ram's core principle of timelessness. The prompt explicitly instructs the AI, avoid trendy jargon. Rely on established, durable principles rather than the current hype cycle.
That makes a lot of sense.
Words like delve and vibrant tapestry are deeply tied to the current AI hype cycle. In 2 years, any text containing those words will instantly look laughably dated, much like a website from 1998 covered in flashing GIF banners. Plain, direct, unadorned English is timeless.
The structural bands in the prompt are just as aggressive as the vocabulary bands. It explicitly forbids the AI from using what it calls negative parallelisms to sound insightful.
Give me an example of that.
So the AI is not allowed to say things like, it is not just about efficiency, it is about creating a holistic workflow.
Because that is a cheap rhetorical trick. It is a pacing mechanism used by human politicians and essayists to sound intellectually deep while artificially inflating their word count.
Right, it doesn't actually add info.
But for a machine tasked with delivering pure utility, it is a complete waste of compute and screen space. If the answer is X, just state X.
It also bans the rule of 3 for padding descriptions. The model is forbidden from describing a system as fast, secure, and reliable unless those 3 specific adjectives are mathematically vital to the functional answer.
Such strict parameters.
It commands the strict use of basic verbs like is or are instead of flowery, descriptive verbs like serves as or represents. And my absolute favorite rule in the entire document, never start a sentence with additionally or furthermore.
Oh, I love that one.
Yeah.
Because if you have to begin a sentence with the word furthermore, it proves that you failed to organize your logical structure correctly in the previous paragraph.
Exactly.
You were just tacking on afterthoughts. This prompt forces the model to structure its entire output perfectly before it generates the first token.
And it culminates in this ultimate mic drop instruction. The final command the system prompt gives to the AI is this. When the user asks a question, provide the simplest, most highly refined answer possible. Stop generating text the moment the functional requirement is met.
Stop generating text. It is such a beautiful command. It is the ultimate antidote to the endless scrolling, the bulleted lists, and the rambling, sycophantic outputs we have been conditioned to accept.
It's so refreshing.
It fundamentally forces the AI to have an off switch. Once the nail is driven, put the hammer down.
So what does this all mean for us? Let's synthesize the sheer volume of technical and philosophical ground we've covered in this deep dive. We started by dismantling the illusion of the search engine.
Right, moving away from keywords.
We established that these models are probabilistic engines operating in a multidimensional latent space. And to control them, we must use the rigid architectural framework of persona, task, context, and format. We learned that mechanical consistency, refusing to use synonyms, is mathematically necessary to maintain the model's attention weights.
We examined the physical limitations of the technology, too, acknowledging that because the model lacks embodied cognition, it will hallucinate solutions that defy real-world logic.
So we have to check its work.
This requires us to constantly evaluate outputs for accuracy, statistical skew based on training data, overrepresentation, relevancy, and consistency.
We analyze the mechanics of iteration, how adding tight constraints radically reshapes the probability distribution of the output, and how sequencing prompts prevents the model's logic vectors from becoming entangled.
And we defined the context window and the key value cache,
proving that you must start a new chat to prevent context bleed from contaminating your workflow.
From there, we scaled those exact same foundational principles to orchestrate complex multimodal generation. We saw how a disciplined application of structured English allows a single user to navigate from text-based conceptualization to diffusion-based image generation, all the way to synthesizing temporal motion vectors in VO 3.1.
And finally, we stripped away every single layer of excess with the Dieter Ram's paradigm. We discovered that the most sophisticated way to command artificial intelligence isn't necessarily to ask it to produce more content, but to violently constrain it,
To hold it back.
to forbid the conversational filler, to ban statistical artifacts like delve and tapestry, and to demand that accuracy and brevity be treated as the ultimate form of respect for the user.
If there is one overarching thesis you take away from these sources, it is that control is entirely in your hands. A large language model is not a slot machine that you pull a lever on and passively hope for a jackpot.
Right.
It will perform exactly to the standard you enforce. If your instructions are vague and conversational, the mathematics dictate that your results will be messy, generic, and full of friction.
But if you do the work,
But if you enforce structural discipline, if you mathematically constrain the probability space, and if you demand that the machine operates as a strictly utilitarian tool, less but better, it ceases to be a novelty. It transforms into a razor-sharp, highly predictable extension of your own cognitive process.
a razor-sharp extension of your own cognitive process. I love that. And, looking back at the sheer rigidity of that Dieter Rams prompt, it leaves me with a really provocative thought to mull over.
What's that?
Well, in order to get a piece of artificial intelligence to communicate with clear, honest, and truly useful brevity, we literally had to write a complex, restrictive, multi-paragraph cage of a system prompt.
We had to force it to behave.
Right. We had to forcefully command the machine not to use filler, not to use trendy buzzwords, and not to pad its answers with cheap rhetorical tricks just to sound smart.
Yeah, that's true.
It makes you wonder, if we have to program our machines so rigorously and aggressively just to get them to communicate cleanly and honestly with us, maybe we should be actively applying those exact same but better constraints to how we communicate with each other in our own daily lives.
Oh, it's interesting.
Think about the murky waters we talked about at the beginning. Maybe the murkiness isn't just a flaw in the machine's latent space. Maybe it's a flaw in how humans talk. What if we stripped away the furthermores, the synergies, and the vibrant tapestries from our own emails and meetings, and we just learned to stop generating text the moment our functional requirement was met? That's something to think about.